Hello. So today we are going to be talking about equations and how it is we can solve equations and what they mean. So to begin with, we're going to look at where we've seen equalities or equations before, and we've been seeing them for a very long time. If we have something like 3 plus 7, we'd say that was equal to, we add them together and we get 10. So what does this mean? It means that the left hand side is equal to the right hand side. They are the same. So this is really the same as this. Now 3 plus 7 looks different to 10, but we know that in actuality this is exactly the same as this. So we put an equal sign in between two things that are the same as each other. So the left hand side is the same as the right hand side. That's the key idea that we need with equations, and it really is as straightforward as that if we can really understand and keep track of that fact. So the left hand side must be the same as the right hand side, even if it looks different, just like this looks different to this, but they are in point of fact the same. And if we can really keep that in mind, it will help us a lot with doing this type of work. Now, when we are doing equations work, we are often, or always effectively, going to have in the back of our minds this picture here. So this is my attempt at drawing a weighing scales. So this is a way of seeing that the stuff on one side, this side here, has the same mass as the stuff on this side here. And we know that by the mass balance, or the weighing scales, being balanced. So our bar is straight across. If our weighing scales was disbalanced, if it wasn't a balanced scales, it would look like this. This would be an unbalanced scales. And what would have happened there is there'd be more mass here and less mass there. So it would end up unbalanced. And when we're dealing with equations, we're going to start out with one side of our equation is going to be equal to the other side of our equation. So we'll have a balanced scales. We'll have something like 3 plus 7 on one side, and we'll have 10 on the other. So this is the same as this, so they are balanced. If this was 3 kilograms plus 7 kilograms, it would be equal to, it would be the same mass as 10 kilograms. If we're thinking about an experiment we might do in science, we have a balanced weighing scales. So the masses are the same on both sides. And if we can keep the masses the same on both sides of our weighing scale, that means that we've balanced our equation and we haven't broken any rules of maths. Now, this is going to be to do with algebra. So what I'm going to do is give you an example. Instead of with pure numbers, I'm going to give you an example with letters in it. So if we draw our mass balance again, if we draw our weighing scales again, I'm going to say that I have a number and I don't know what the number is, so I often call it x. And if I add 5 to a number, I end up with a total of 20. So I have a balanced weighing scales, and I have some number of kilograms plus 5 is equal to 20. So how would we write that mathematically? We'd say we had x plus 5 was equal to 20. And I want to know what this unknown mass is. How many kilograms is x? So x is a particular mass, and I want to know what x is. How heavy is x? Or what mass has x? So x plus 5 kilograms is equal to 20 kilograms. Now instinctively, we probably all know that it is 15 kilograms, but we want to look at how we would figure that out. Well, if we were going to use our weighing scales here, what would we do if we wanted to use our weighing scales in order to figure out what mass x was? Well, we have x plus 5 kilograms here is equal to 20. If I removed 5 kilograms If I took away 5 kilograms from this side, so I have my 5 kilogram mass and I lift it off of this side of my weighing scales, I'd be left with just X on this side of my weighing scales, which is what I want. But if I only took 5 kilograms off of my left hand side of my weighing scales, I'd end up with it disbalanced. I would end up with a smaller amount of stuff on the left hand side than on the right, because I've taken 5 kilograms off of my left hand side. So to keep everything balanced, I have to take 5 kilograms off of my right hand side. And when I do that, I'm going to be left with X is equal to 20 minus 5. So on this side, I've removed 5 kilograms, so I'm left with X. And on this side, I have 20 minus 5 is 15. So what did I do? I took away 5 kilograms from the left hand side, and to keep everything balanced, I had to take 5 kilograms off of the right hand side, because otherwise I would have broken my balance. This side would have ended up heavier than this side because I'd taken 5 kilograms away from the left. But here I can see I still have a balanced scales because I did the same amount of work. I took 5 kilograms off of both sides of my weighing scale. Well, what's that going to look like when we have an equation, when we have our algebra the way we usually write it? Well, I have X plus 5 on one side of my weighing scales, on one side of my equal sign, and then I have 20 on the right hand side of my equal sign. So what am I going to do? I want to know what X is, so I don't want this plus 5 here. So I'm going to take 5 away from both sides of my equation. I have to take it away from here, so I'm left with X. And to keep the balance, I have to take it away from the right hand side as well, so I end up with 15. So that's how I work out my equations. The first type of equations I have to deal with. I'm going to get rid of the number that is sitting next to my X. If I do another example here, I'm not going to draw a picture for this one. We don't have to draw a picture. We just want to keep this image in the back of our minds. If I had H minus 10 is equal to 50. So I want to know what H is, and if I take 10 away from H, I'm left with 50. This is equal to this. They're the same. Now I want to know what H is by itself, and instinctively I probably know that it is 60. I have a number, I take 10 away from it, and I'm left with 50. So that number must be 60. But how are we going to write that out? How are we going to reason that out? Well, I want to just have H by itself, and at the moment I have H minus 10. So I don't want this minus 10 here. So how am I going to get rid of minus 10? Or how am I going to make this go to 0 effectively? Well, if I'm at minus 10, how do I get to 0? I would add 10. And if I add 10 to the left hand side, to keep my balance, I must add 10 to the right hand side. So I end up with H is equal to 50 plus 10 is 60. So there is an example where I would have a negative number. And I'm going to do one more example for you. Not going to be any different, but if I had something like m plus 3 is equal to 27, we'll say minus 27. So m plus 3 is equal to minus 27. How am I going to find out what m is? Well, I have m plus 3 is equal to minus 27. I don't want this plus 3 here. I want m equals a number. So how am I going to get my plus 3 to go to 0? Well, I'm going to take away 3. So if I start at plus 3 and I want to end up at 0, I would take away 3. So m plus 3 is equal to minus 27. I take away 3 from the left hand side, and then I must take away from the right hand side as well to keep everything balanced, because if I took 3 away from the left hand side and didn't take it away from the right hand side, I would have broken my balance. I would have less on my left hand side than I would on my right. So when I do that, I have m plus 3 minus 3, so plus 3 minus 3 adds up to 0, so I'm just left with m on the left hand side, and on the right hand side I have minus 27 minus 3, so I end up at minus 30. And remember, the way we do these questions is using our number line, so picture the number line in your head. And those are the skills that we need for starting off our work in equations.